trigonomic identities. In mathematics, an identity is a result which is true for all variables x. So essentially a true statement. These are some of the ones we're going to focus on today. We should already know that tan of it, we should know this basic identity, which is tan of x equals sine over cosine. So tan is sine over cosine, that's an identity. And we'll cover some of these more today. So first thing, our first example here is we're going to simplify this expression. So when you simplify a trig expression, it's a lot like simplifying a variable expression. All you do is add like terms. So for example, if I gave you 2x plus 3y plus 2x, I can add the x's up, and you just added like terms. Same thing here. You have 3 cosine theta plus 4 cosine theta. 3 plus 4 is just 7 cosine theta. Works the same way. If you subtract 10 alpha, it's a lot of times when we do angles, we do Greek letters, so theta, alpha. And this problem is just 1 tan alpha minus 3 tan alpha, also known as negative 2 tan alpha. So that's how you simplify a trig function, just like any other variable function or radicals to treat the exact same way. Let's talk about some other angle relationships. Now these are not in the formula sheet for IB, but they kind of do expect you to know some of these. There's not as bad as it look. The first one is sine is what we call an odd function. So if there's a negative inside of it, you can pull it out. So that only works for sine and tan, but for sine, it's an odd function. Cosine is an even function. It's the only trig function where if you have a negative inside, it just goes away. So cosine is an even function, sine is a sine function. We have the supplementary angle formula. If you do sine of pi minus theta, you just get sine back again. If you do cosine pi minus theta, you actually get negative cosine. And the one that IB would probably use the most are these two right here. Sine of pi over 2 minus theta is just cosine, and likewise cosine pi over 2 minus theta is just sine. It has to do with the graphs. Well, it has to do with everything for them, but if you think about the graphs, right, sine and cosine, they're the same graph. This is sine, this is cosine. If you just move it over pi over 4, you kind of start right here, and you get a cosine graph. Hence, the formula. So, those are the trig functions we're going to use here. So, sine is an odd function, pull out the negative, cosine is an even function, goes away. If you see sine or cosine of pi minus theta, it's the other function, cosine is a negative version of it. And if you see pi over 2 minus theta, that's just the other function. So if I was going to simplify some of these, sine is an odd function, so I can pull out that negative, it's just negative sine theta plus 2 sine theta. And then we just add like terms, so I get 1 sine theta, negative 1 plus 2. Over here, so testing our formulas here. So the pi over 2 minus theta, that's the one where it's just opposite, so this is sine theta. And cosine of pi minus theta, where it's just a pi, that's the same one, but cosine does have a negative. If it was sine, it would just be sine, but cosine is a negative version of it. So negative cosine theta. And we're not going to leave it like this. We know what sine over cosine is. That's our first identity we learned. That's tan. And since there's a negative on the outside, there's a negative on the outside. And you just simplify that trig function. So general key, if it's pi over 2 minus theta, it's just the other one. So sine's cosine, cosine sine. And if it's just a pi by itself, it's its own thing. Cosine is negative though for that one. Let's talk about the most famous and important identity, the Pythagorean identity, off of Pythagorean's theorem. So where does this come from? Well, if we look at our unit circle, any point along that unit circle is an xy point. So if we make a little triangle here, this is x, that's y, and now we have a little right triangle. And since it's a unit circle, the hypotenuse is only 1. You get x squared plus y squared equals 1. Pythagorean theorem. But don't forget, x is just the cosine value. So cosine squared plus, and y is the sine value. Sine squared equals 1. So that's where it comes from. It comes from the unit circle. It comes from a squared plus b squared equals c squared by Pythagorean theorem, but for a unit circle. So that's this famous formula is from. This is in your formula sheet. You just get to use it. However, what they don't put is the other two formulas are equivalent, but just as helpful. If I saw this formula for sine, like it subtracts sine from both sides, these would cancel out, and you just get cosine squared equals 1 minus sine squared. And this is equally as important. We use this almost as much as we use the other one. If we do the same thing for cosine, like you saw for cosine, so solve for sine, subtract cosine from both sides, you get sine squared equals 1 minus cosine squared. So all three of these formulas are equally important. Maybe this one's the most important, but these are very, very important also. So sine squared plus cosine equals 1. That is in your formula sheet. You do get to use it, but you got to remember yourself that you could solve for sine, get rid of the cosine, and get sine squared equals 1 minus cosine squared. Or you can solve for cosine, get rid of the sine, and cosine squared equals minus sine squared. So see how we use this. So I'm going to leave it just like right there. So one right here, they want me to simplify it. Well, the first thing to notice is that they both have a 2. So we can factor out a 2. Factor out 2, just divide by it, and you get this. 2 times 1 minus sine squared, right? But we just saw that. 1 minus sine squared is cosine squared. So just the same thing, just saying 2 cosine squared. There you go. With this one, we want to simplify. Another thing I notice, so they all have a sign. So let's factor out a sign. Oops, I made sine squared, I missed my sign. And I'm left with cosine squared plus sine squared. That should be the most famous formula we do today. That is 1, right? Pythagorean theorem. So I have sine times 1 or just sine? Oh, that one's great. Next, let's do a couple more of these. Look at them right here. What do you notice they have in common? They both have a negative. So let's factor out the negative. Pull negative 1 out. When you factor out negative, just divide by negative. So it becomes cosine squared plus sine squared. And again, that's just 1. So I just get negative 1. The next one, I get sine squared minus 1. Now they want me to do something with it. So let's just look at what sine squared is. Let's change that. Right? What does sine squared equal? 1 minus cosine squared. So let's change it that way. 1 minus cosine squared minus 1. In that case, parentheses don't really mean anything. The 1's cancel, 1 and a negative 1. I just get negative cosine squared. On the next one, I get 1 minus cosine squared over sine. Remember what 1 minus cosine squared is? I swear that was a word. That is sine squared. So I get sine squared theta over sine theta. And that just reduces. You just get sine. Moving right along here. This time they want me to expand cosine squared minus sine squared. So the key thing here is don't be lazy. You don't just put the square to both of them. That's bad algebra. Just see what squared means. Multiply by itself. So I get that. Theta. I'm very bad at putting in thetas. You're supposed to. So now we just distribute, right? So cosine times cosine. Cosine squared theta. Cosine times sine is negative cosine theta sine theta. Then distribute the sines. Sine times cosine, another negative cosine squared sine theta. Actually, let me put sine theta cosine theta to prove a point in a second. And then plus, when we multiply these, double negative is a positive plus sine squared theta. Okay, so what's the next step? First, I want to point out these two here. One is cosine sine, one is sine cosine. They're exactly the same thing. Technically, you're supposed to have alphabetical order, so this really should be negative cosine theta sine theta, but doesn't really matter. So they're both the same. I just add them up. I get cosine squared theta minus 2 cosine squared, cosine theta sine theta, not squared, plus sine squared theta. You might think, what's next? Well, what do you notice? I got a cosine squared and a positive sine squared. That's a formula. If I look at these two, cosine squared plus sine squared equals 1. So that just becomes like a positive 1. And my answer is going to be 1 minus 2 cosine theta sine theta. Right? Cosine squared plus sine squared is turned into 1. So I have this and the positive 1. Let's move the positive 1 in the front to make it a little nicer. And that's my answer. Now going backwards, so we distribute. Now they want us to factor. So I get cosine squared minus sine squared. If you have a hard time factoring that, it's always just like I pretend it's two different variables. One's cosine, one's sine. Well, that should be a difference of two squares. X minus y, x plus y. is the exact same thing. That's cosine, that's sine. So it'd be cosine alpha minus sine alpha. And then cosine alpha plus sine alpha. Right? So either sub in x for cosine and y for sine and plug it in, or just realize the difference two squares and factor that accordingly. As far as I could go. This one, they're all the same variable. So in that case, I think my favorite trick is just pretend it's like they're all like an x. This is x squared, that's 3x, and that's positive 2. So you just factor like normal. That'd be x minus 2, x minus 1. Right? Both things multiply to get 2, but add to get negative 3. And then you just put the trig function back in this case 10. So 10, I'll put theta minus 2, 10 theta minus 1. And that's the idea. Next one. I want to simplify this. Now we're going to kind of put different ideas together. So here, first thing I notice that they both have a 2, so let's factor that out. I'm going to get 2, 1 minus cosine squared theta over 1 plus cosine theta. Now this is a little tricky. Normally, I'll probably change 1 minus cosine squared to sine squared. But that's not going to give me anything here, right? I have a 1 plus cosine squared. Look at this guy again. 1 minus cosine squared. That's a difference to 2 squares. It's like having 1 minus x squared. Difference 2 squares. 1 minus x, 1 plus x. That's what's going on here. I'm going to factor this to 2 times 1 minus cosine, 1 plus cosine, all over 1 plus cosine. And now they cancel out. Because they're both being multiplied, so you can cancel them out. And then you're left with just 2, 1 minus cosine theta. Or if you want, 2 minus 2 cosine theta. So again, you can't just cancel out the cosines here. It doesn't work because it's inside the plus minus. There's an implied parenthesis right here. They have to be exactly the same to cancel out. I would probably make that, normally I would make that sine square, but then I noticed, wait, that's not going to help me. I have a cosine bone I can't cancel. So anything else I could do? Yes, that's the difference of 2 squares. So just like having 1 minus x squared, 1 minus x, 1 plus x, same thing here. 1 minus cosine, 1 plus cosine. Now the 1 plus cosines cancel. You just get 2 times 1 minus cosine. Or if you want this. So look at this one. Let's kind of try to do the same idea. Now on the top, I already can't do anything. It's cosine minus sine. It's pretty much stuck. But the bottom has cosine squared minus sine squared. That's a difference of 2 squares. So I could write that as cosine x, or theta, minus sine theta. And cosine theta plus sine theta. On the top, I just leave it. Cosine theta minus sine theta. If you notice, these two cancel out. They're exactly the same. And again, there's an implied parenthesis there on top. It's always like if you have 2 plus 1 over 2, the 2's don't cancel out. There's an implied parenthesis here and here. So this is actually just 3 over 2. You can't simplify it that way. It'd be multiplying. That's what's going on here. There's nothing up here. These two, but these things are multiplying, so I could cancel out these. I just get 1 over cosine theta plus sine theta. Just to show the difference. This cancels out. This no. That's that one. Two last ones. This one's a little different. They want me to show these two things are equal, so they want me to verify these are the same. Now, anytime I do one of these, I always work on the harder side. Like I can't do anything here, but this side, I could try to do like a common denominator thing to add the fractions, because this is one fraction, but these are 2 fractions. So let's try to combine these. So just using good old common denominator skills. This is the denominator here is 1 plus cosine. I don't have the sine, so let's multiply both top and bottom by sine theta. I get sine squared theta. And here's a little pro tip. Don't distribute the bottom. We want things to cancel out, so you just leave the bottom the way it is. How about on this side? Well, it has a sine, but it doesn't have the 1 plus cosine. Let's multiply by 1 plus cosine. So I get 1 plus cosine squared, which I might need to simplify later, over sine times 1 plus cosine. Now let's just put it all in one denominator. I'm just going to do that for us. So it's sine theta 1 plus cosine theta. And on top I have sine squared plus 1 plus cosine squared. So again, all I did on this side was combine it. I'm trying to make it look like 2 over sine, which right now does not look like. But let's simplify a little bit more. So only I can do now is simplify this top right here. It's like we talked about last time. Don't be lazy. This is 1 plus cosine times 1 plus cosine. If you distribute that, you should get this. The sine squared from outside. That's from this guy. And then over here, 1 times sine, 1 times 1 is 1. Cosine plus cosine is 2 cosine. And then cosine times cosine would be cosine squared. All on top, and on the bottom I have sine theta 1 plus cosine theta. All this should equal 2 over sine theta. The whole point here is I want these to match. So I'm trying to make this side look like that side. So I can't do anything on this side, just to work on the side alone. Hopefully we notice something special up top here. Sine squared plus cosine squared, that's just the same thing as saying 1. So on top I have 1 plus a 1 plus 2 cosine theta, or 2 plus 2 cosine theta on top. Since sine squared plus cosine squared equaled 1, and 1 plus 1 was 2. And on the bottom I have sine theta over times 1 plus cosine theta. It's closer, it looks a little bit more like that one. It's got to get rid of this 1 plus cosine. But look up here. They share a 2. Factor out that 2. Now that's a 1 plus cosine also. These would cancel out and I'm left with just 2 over sine theta, which matches what it's supposed to. Okay, last problem real quick. They want let's solve an equation with also using these rules. So anytime we see a quadratic here, like right there, you want to set equal to 0. So that's always a step 1. Set equal to 0. So I'm going to get 2 cosine squared x minus 3 sine x equals 0. So now I want to be able to factor and do stuff. The problem here is I have a cosine and a sine. They don't really match. I really can't do anything there. What I can do though is change cosine squared. Right? I have a sine, can't do anything there. I can change cosine squared. Remember what cosine squared equals? 1 minus sine squared. So I'm going to write that there. So 1 minus sine squared minus 3 sine theta sine x equals 0. Now let's distribute and see what we have. So I get 2 minus 2 sine squared theta x minus 3 sine x equals 0. Now I never have like how my squared be negative. So I'm actually moving to the opposite side and I get this. 2 sine squared x plus 3 sine x minus 2, right? So I added this to both sides, added that to both sides, subtracted that from both sides, and I get this. Now what I gotta do is factor that. Again, easiest way to do that for me is just pretend there's not a sign there, pretend it's just like this, and factor this guy. So multiply the first 2, last 2. Find the combination that gets me in the middle. Since it's a negative, one has to be positive, one has to be negative. And the bigger number should be a positive, match that. So 4x and a 1. Plug it back in for the middle. So I get 2x squared plus 4x plus 1x minus 2. These have a 2x in common. X plus 2. Always bring in the middle sign. And these have nothing in common. That should have been a negative one. I messed that up. There we go. Bring in the negative sign. Right, because these had to be 3, and I messed that up for a second. Bring in the negative sign. And then when you factor a negative, that becomes a positive 2. And now they match. Whew, was sweating for a second. So we have x plus 2 and 2x minus 1 equals 0. Now we can sub in back our sign, right? Because I just kind of ignored it. So it's going to be sine x plus 2 and 2 sine x minus 1 equals 0. Split sine of x equals negative 2. We'll talk about this in a second. And then sine of x equals 1/2. Now sine equals negative 2, if you remember, sine can't be bigger. Sine and cosine have to be between 1 and negative 1. So this is actually too big. Actually, well, technically too low. So no solution there. Here, that's a classic problem. So all students take calculus. Sign is positive, so I have it at A and S, and negative down here. I want the positive value, so this and this. Opposite one hypotenuse is 2. That right there tells me this is a 1, 2, rad 3 triangle, and that is 30, because 30 is opposite the 1. So that makes this pi over 6. My favorite trick, this is pi, or 6 over 6. 1 less, 5 pi over 6. Now those are the only answers within the first rotation, first domain, which is all I want, between 0 and 2 pi. So that's my answers, pi over 6 and 5 pi over 6. And that's the video.